So, welcome back. And we have now a very interesting talk from Jakub Zolewski entitled Getting the Most Out of Test-Driven Development for Shiny. Jakub is a senior engineer at Epsilon. He has background in applied physics. Before Epsilon, he worked in insurance and banking as an analyst. He is also a maintainer of the Shiny React and Shiny Fluent packages. Jakub, thank you very much for being here, and the floor is yours.
Hello, thanks for having me. Hello, everyone, and I hope you're enjoying the conference. In this session, we're going to talk about test-driven development and how to do it effectively. I'm Jakub Sobolewski. I'm senior RShiny developer at Epsilon, and I've been using test-driven development for almost 3 years. I used it in a variety of projects, from small prototypes developed in 2 weeks to huge apps developed over many months. I used it to develop R packages as well. So, in this session, we're going to answer 3 questions. What is test-driven development? How to do it in R? And how we can use it to develop Shiny apps? And last but not least, why should we use it? I hope that by the end of the session, you'll have a better understanding of TDD and why it's worth giving it a try. So, what is TDD? It is a technique in which tests help us design our code. It is a guided evolution with clear feedback after each step. And last but not least, it is a process where we write tests before we write the production code. There are 3 steps in TDD. Red, this is where we start by writing a failing test. It will fail because the code we want to test doesn't exist yet. And it will fail as long as we don't solve the problem we stated in the test. This approach is the other way around to test last approach, where we write tests to make them pass. It changes the dynamic between production code and tests. In TDD, we don't try to prove that the code we wrote works as expected using a test. We write code to accomplish what is stated in the test. Green. Once we have at least one failing test, we can write production code to satisfy it. Since we have tests, we can run them as often as we need. We have a reproducible way to check if the code we write works as expected. We don't need to set up the environment by hand each time we sit down to write the code, or to do a lot of clicking in the app if we're developing an app. If the code does what we want it to, tests will pass. And we write only as much production code as needed to make tests pass. Why would we write more code if tests are already satisfied? Don't do it. You ain't gonna need it. Last step is refactoring. Were you ever afraid of refactoring your code because you thought you might break something? TDD helps you mitigate this problem. We have tests that ensure that the code works as expected. So we can be more liberal in changes we make to the code. If written well, tests don't constrain us. They empower us to make bold changes. And we don't only want to have working code. We want to have good code. We can spend some time to make this code more clean and easy to understand. We might also want to optimize it. So let's see in practice how this process looks like. First, we will implement a simple function that adds numbers. It will be a simple example, but it will show you how the process works. We start from writing down a title of the first behavior we want to implement. This can be the simplest case, just to get us started. The next step we're about to do was the most scary part of TDD for me, but it was scary only at the beginning when I started learning it. How can we write a test when there is no code to test? It is useful to remember that each test consists of three parts: setup, execution, and assertion. We can use arrange, act, assert comments to split our tests into those distinct parts. And we start with the setup. This is where we prepare the environment. This is where we need to figure out the inputs required to solve our problem. This is a very powerful technique. Why? At this stage, we focus on what we need to be able to solve the problem, not how we will solve it. Without understanding the problem, we won't be able to write down the test. And this is good. We won't write any production code until we have understanding of the problem. This helps us mitigate the risk of implementing the wrong solution. Act is where we call our code, and TDD gives us the freedom to experiment with interfaces. We can try out a few different variants even before we start writing the production code, possibly saving a lot of time on refactoring. The test you write is the first user of your code. The way you call your code from tests is the way you will call it from the production code. So think about how you want to use your code before you start writing your tests. And in assert, we focus on how to observe that the code works as expected. Again, we won't be able to do it without understanding the problem. We should know what is the expected output for given inputs. Although we could skip this part of writing down the assertion, but only a few iterations of prototyping to help us understand the data better and to design our output the way we want it. So in TDD, we first define inputs and outputs, treating the not yet existing code as a black box. This approach produces tests that don't test implementation details. It's impossible to do so, since there is no implementation yet. It makes tests focused on the behavior of the code. So now we have our test, we implement the function with the interface we want to use. And we might observe a different test output. Now it's a failure due to the function returning the incorrect value. To make the test pass, we could provide the simplest implementation. And if this was the only usage of this function to sum two numbers together, this implementation would be completely sufficient. But we want it to work for more cases, not just adding two numbers together. We add another case. We expect it to work with a single number. And this implementation no longer does its job. We need to change it. Our first approach might be to do a simple for loop. And it's enough to make tests pass. They are green now. We implemented both behaviors that we wanted. And now we might refactor the code to make it cleaner or more efficient. So this was easy, but how do we use it to solve more complex problems? There are two distinct approaches we could use. Bottom-up is where we start small with the smallest piece of the problem we can solve. We use existing pieces of the code base as we go, and we don't know upfront how the solution will look like. We let the design emerge from the tests and code that we write. The other approach is top-down, where we focus on high-level objectives first. We describe the behavior from user perspective. If it's a Shiny app, this is the perspective of the user interacting with the app. If it's a package, this could be a perspective of a user that uses our functions exported from the package. And we fill in the gaps until tests pass. So how do we choose the correct approach? If we're developing a Shiny module, a list of user behaviors we want to implement can be more useful. Then we do top-down approach. And if we're developing some computation, maybe it's better to start from the smallest piece of the algorithm and build up from there. Then we go with bottom-up approach. We do what helps us move fast and obtain our goal. This is what test-driven means. Tests drive the development process. They tell us what to do next, and if the code that we implemented does what we think it does. So what to do when we have some requirements from our clients that we need to implement? How do we get from some descriptions to tests? We need to use specific examples. Examples are translatable to tests. Examples help us understand the problem better. Abstract descriptions don't have these properties. So how do we get these examples? A common way of writing down the requirements are acceptance criteria. They are a list of verifiable statements. For example, something should do something, or something should do the other thing when something else happens. They should be clear so that everyone understands them, and they should be concise so that there is no ambiguity. See how easy it is to put those descriptions into a test file. Then we can start filling in those test cases with code. So let's see some tips on writing test cases. They should be specific for low-level tests when we have very specific input and output. We should be specific for tests of business logic and for edge cases. So instead of saying something should work correctly, we should say, for example, that it should throw an error when the table has one row. For higher level tests, as tests of Shiny modules, it's better to make them more abstract so that they will be true, even if the implementation details change. For tests of a Shiny module, don't tie requirements to the UI. Focus on the business goal. Write those requirements such as if you've never heard of buttons, dropdowns, or inputs. This is the key to having test cases decoupled from the implementation details. So you see that this requirement that is crossed would no longer be valid if we just change the label of the button or if we removed the button altogether. But the second example is that it should show the summary, and the business goal should be always valid, and no matter how it's achieved, it will always show the summary. So this means that tests can show that we solve the problem. Tests can document our code, and this documentation will be valid as long as our tests pass, compared to code comments or other documentation types that can get outdated anytime. And this also means that we can use tests to communicate with our clients better. Tests can empower our clients to cooperate with us more closely. Then our clients could provide us examples, which we then translate into tests. And tests become artifacts that they can inspect and validate on their own if we implemented and solved their problem. So let's see how we can use TDD with Shiny. There are 3 things we need to know before we start. The testable unit of a Shiny app is a Shiny module. And that a module can represent a feature. And by feature, I mean a part of the problem we are solving with the app. And we need to remember that we can easily run modules as standalone Shiny apps. Let's head over to an example. we will implement a simple module that shows a summary of a dataset. We start from an empty test, same as we did in the first example. Tests are red. Then we go over to setting up the environment. We create a Shiny app from the not yet existent module. Then we may create an object that will represent this module. It will be a proxy for communicating with the module. We will create it in the next steps. For now, our only focus is to imagine how we want to use it, how we want to interact with the module. We provide human readable methods that will hide implementation details of the test. It will make tests easier to understand and maintain. Instead of using an object, we could use functions. This doesn't matter. Do what feels more natural to you. The important part is that we're abstracting and reusing the actions we can take on the module. In this test, we don't do anything in the execution part. We will test the default behaviors when no actions were taken. So it's about the initial state of the module when it first appears on the screen. And we want to assert that the summary is visible on the screen. When we provide the skeleton of the module, the test failure message changes. Now we need to implement our dataset summary object. This is where Shiny Test 2 comes in handy. We can use it to interact with our app, but only from within this dataset summary object. It will ensure that no implementation details of the tests are leaked into test code. Everything should be contained within those methods. And now at this point, we might realize that we need some data to show in the summary. And we can provide it through some data provider object. This could be an existing object in the app, or if we're starting a new app, this can be a fake object that represents how we want to get the data. This allows us to test the module in isolation without the access to the real data, without access to, for example, a database. And now we are evolving our interface of the module so that we can pass the data provider. And notice how this approach promotes dependency injection. Now we can focus on the assertion. I'm using functions from Selenider package here that provides a few nice assertions on an object that we can derive from the app driver. And think for a moment what outcomes means to you that you met your objective. In this case, asserting that the table is visible and that it has at least one row might be a good way to ensure that the summary is shown. But notice how this is in a method. This way we can reuse it in other test cases. And if at any point in time our understanding changes, we can change the implementation of this method and all tests will be updated. Once we have the assertion in place, we can implement the module to satisfy the tests. Notice how we are testing the module with fake data provider. The actual data provider should be tested in isolation to make sure it serves the correct data. By adding a call to a Shiny app in our test file using the same setup as in tests, we can run it interactively. This way, we can quickly iterate over the design and make the interface more usable and beautiful faster, without having to run the whole app. We can use this also to do manual exploratory testing or debugging. This is our entry point to the feature. So we have developed one feature. We can expand it with new specification. We can also add new features, new modules, new test files. Those are high-level tests of Shiny modules that check if we achieve our business goal. We supplement it with regular low-level unit testing that validates business logic. And this is how we end up with tests for all building blocks of the app. We test and develop the parts separately, and the sum of the parts is the whole app. This approach helps us maintain development speed even as the app grows. So why should you give it a try? To have faster development cycles with clear feedback, to understand the problem better before you start writing the code, and to have confidence that what you're developing is what you need. Also to have confidence that if you change something, the rest doesn't fall apart. Thank you for joining me today. And if you want to read more about TDD or testing in general, follow me on LinkedIn, where I post updates, when I write something new on the subject. You can also check out my blog, where you can find all the resources I've written so far. And if you want to dive deeper into the world of high-level, top-down, user-focused testing, check out my Cucumber package. It might help you with developing your Shiny apps from the user perspective, especially when you have a lot of behaviors to implement. Thank you once again, and enjoy the rest of the conference.
Thank you very much, Jakub. I think it has been a great talk, and we all have learned a lot. And I would have one question, that has just been asked right now. Is well, that will be the first. The first question will be: is there something specific that you liked about the describe or the it framework from test.dat over using directly the test.dat function?
Well, to me, the advantage of using describe and it is how it makes test cases read like natural language. We're describing something, some object, a feature, and then we say that it should do something. It should do the other thing. So it fits perfectly with the framework and describing the behavior of the code.
Yes, thank you. So I think we are over time, so we don't have time for more questions. But I thank you again for this presentation.